Today, I'd like to take you through the fascinating world of battery testing. As batteries become increasingly central to our energy future, understanding how they perform under various conditions is more critical than ever. When developing new battery technologies, we employ a comprehensive range of testing methods. These include electrical tests to evaluate capacity and charge-discharge rates, thermal tests to assess performance across temperature ranges and thermal runaway behavior, chemical tests to analyze material composition and electrolyte properties, and environmental tests to determine resistance to humidity, vibration, and altitude changes. Among these testing categories, mechanical testing stands out as particularly crucial in modern battery development. Mechanical tests are divided into two main approaches: non-destructive methods, which allow us to examine batteries without compromising their integrity, and destructive testing, which deliberately pushes materials to their breaking points to determine their ultimate limits. Destructive mechanical testing has taken on increased importance recently for several key reasons. As batteries are integrated into more applications, from electric vehicles to medical devices, understanding the mechanical failure modes becomes essential for safety. Additionally, as we develop new cell chemistries and form factors, mechanical testing helps ensure reliability throughout a battery's life cycle, including during manufacturing, transportation, installation, and operation under various stresses. Let me walk you through the 5 most critical mechanical tests we perform in battery development. First, tensile strength testing. This fundamental test evaluates how materials respond when pulled apart, a critical property for components like aluminum and copper current collectors and separator foils. These tests help us understand the material's elasticity, yield points, and ultimate strength, ensuring that they can withstand the stresses encountered during manufacturing and operation. Second, shear and peel tests. These evaluate bonding quality, how well different materials stick together. We use them to measure adhesion strength of active materials to current collector foils, the integrity of welded seams in pouch cells, the strength of terminal connections, and the robustness of tab welds. These interfaces are often the weakest point in a battery, making their testing essential for long-term reliability. Third, penetration testing. This critical test measures resistance to mechanical impacts by forcing a probe through materials like separators and pouch enclosures. We also conduct nail penetration tests on complete cells to evaluate how a battery chemistry or design responds to internal short circuits, helping us develop batteries that fail safely rather than catastrophically. Fourth, compression testing has become increasingly important as we develop new battery technologies. These tests help us understand how materials behave under external and internal pressure, vital for active material powders, protective layers, and complete cells. Compression data is particularly valuable for computational modeling and simulation processes that guide design decisions. This testing is also crucial for emerging technologies like solid-state batteries, where mechanical properties significantly influence performance. Fifth, bending tests reveal critical information about electrode flexibility. They help us to identify potential issues like active material delamination or cracking, which can cause premature failure. These tests are particularly important for understanding how electrodes will behave during manufacturing processes that involve winding or folding. In conclusion, mechanical testing provides essential insights that drive battery innovation forward. Understanding how battery materials and components respond to physical stresses helps us create safer, more reliable, and longer-lasting energy storage solutions. If you'd like to learn more about optimizing your battery testing processes or need assistance with your specific testing challenges, our team of battery testing experts is ready to help. Thank you for your attention, and I look forward to discussing your battery testing needs.